Alright, next video, extending the rules of exponents. Here we go. So, part A says, what does 16 to 3 halves mean? So, 16 to 3 halves power. Alright, so that's our first fraction. So we've dealt with whole numbers there. We've dealt with negative numbers, so now we have integers, and now we have rational numbers. So we have 3 halves. Alright, so what does that mean? Do I cube it? Do I square it? Do I do both? And I'm going to show you that we have 3 different methods here to doing this. Alright, some methods are obviously easier than others. Alright, I think depending on the problem, which way is the easiest route will depend. Okay, so we got Mary's method here. She said 16 through 3 halves is equal to, so she wrote 16 to the 1/2 power in parentheses and then times 3. And how is that so? Well, if you recall the rules of exponents, if you have a power to a power, then you would be multiplying 1/2 times 3, or in this case 3 over 1, which is 3 over 2. So what she did was just split it up, which is more than legal. Okay, which brings us to another piece here. So now we have in parentheses 16 to the 1/2 power. So now, any number to the 1/2 power, this is the same thing as writing the square root of 16. Okay, so 16 to the 1/2 power is the square root of 16. If I were to write 16 to the 1/3 power, then this would be the cube root of 16. If I were to write 16 to the 1/4 power, then this would be the 4th root of 16. And so on, right? 5th root of 16. Okay, so the square root is 16 to the 1/2 power. So if we go off of that, 16 to the 1/2 power, so this part here, 16 to the 1/2 power, again, is the same as writing square root of 16, which is 4, and then I'm cubing it. Right? So 4 times 4 times 4, and I get 64. So that's Mary's method here. Alright, so we'll take that and let's group that for a second. We'll move it over to here. That's Mary's method, and I'll unlock these in a minute just to give myself a little space here. Okay, right. And then Luttrell's method. So Luttrell wrote the same thing. He said 16, and this time he did, well, 16 cubed to the 1/2 power, right? Because now that will be the same thing that we did here, where I'm going to be multiplying these two exponents, except what I would have to do first is take 16 to the 3rd power, which is 16 times 16 times 16. And you have a calculator, so it's not horrible if you have a calculator, but if you're trying to do that part mentally, you're going to get a bigger number, so you can get 4,096, and then raise that to the 1/2 power. And now, again, what does that mean? This means the 1/2 power implies take the square root of 4,096, which you may not know off the top of your head. I mean, I definitely don't, but it happens to be 64 as well. So, Luttrell's method. Cool, but your numbers got a little bigger here. So far, I take Mary's method where I took the square root of the number first and then cubed it. So by taking the square root of the number first, I made the number much smaller. I took the square root of 16 first and turned it into 4, and then cubed 4. Rather than cubing 16, and then taking the square root. And then the last one here, another method's cool. All right, so Jacayla's method was saying, so she said, well, I'm going to take 16 to the 3/2 power, and I know when you multiply exponents, so if you have a to the m times a to the n, then that would equal to a to the m times n. Well, 3/2 is a combination of 1 times 16 to the 1/2. So 1 and 1/2, right? 1 and 1/2 is 3/2 as a mixed number. So she said, well, this is 16 to the first times 16 to the 1/2. If she wrote them as a product, which, okay, so you have 16 times, and again, 16 to the 1/2, right? 16 to the 1/2 is the square root of 16, and the square root of 16 is 4. And then 16 times 4 is 64. So 3 methods to do any one of these problems. Okay, so we have, in general, the nth root of a to the n power. Okay, can be written as a fraction, so the nth root is the fraction or the denominator part of it, and the m is the numerator part of it. Right, so the root will always turn into, so square root is something to the 1/2 power. The cube root is something to the 1/3 power, and so on and so on and so on, right? So the root is the fractional exponent. Alright, and then the number on the outside is just the numerator of the exponent, just like everything else we've been doing. Alright, and there are different ways to evaluate some of these, okay? So you have a couple examples here coming up. I'm going to skip number 2 for a second and come to this one. So it says write the following radicals, and a radical is something that has a root, so square root of 5, the cube root of 7, the fifth root of 2. These are all called radicals, okay? So square roots, cube roots, fifth roots, any kind of root are called radicals. And I want these in exponential form. So for part A, the square root of 5, well, this is going to be 5. Well, there's technically an imaginary 2 there that we don't have to write. When it's square root, it's understood. So the number on the inside of the root is 2, so it's 5 to the 1/2 power, or 1/2 power. For B, that number there is 3, so it's 7 to the 1/3 power. And then lastly, for C, it's 2 to the 1/5 power. And that's writing radicals in exponential form. Then we have simplify, part C. Well, okay, so 49 to the 1/2 power is simply the square root of 49, which is 7. Alright, and then this one is the cube root of 64. Okay, so this is the cube root of 64. So what number times itself 3 times will give you 64? So 4 times 4 times 4, right, is 64. So the cube root of 64 is, what number times itself 3 times will give you 64? The cube root of 64 is 4. So you notice 1, 2, 3 4s came out as the answer 4 when you have a cube root. This is the fifth root of 32, and one number times itself 5 times will give you -32. So -2 times -2 times -2 times -2 times -2. So I wrote that -2 5 times, right? So 2, 4, 8, 16, 32. 5 negatives will stay negative. So the fifth root of -32, what's the root of all that? The root is the -2. Right? I'm just taking all those 5 of those -2s and just writing, well, the root is -2. Right, so -2 to the 5th power is 32. The fifth root of -32 is -2. Right, so let me say that one more time. So -2 to the 5th power is 32. If you go backwards, oh sorry, -32. -32 to the 1/5 power, right? So the opposite there is equal to -2. Right, so hopefully you can see that there. And then you have the last one, part D, 81 to the 1/4 power. So, or the 4th root of 81. You might not know off the top of your head, but if you think about what number is multiplied by 81, it's 9 times 9, or you could think about this as 3 times 3 times 3 times 3. So multiplying 3 by itself 4 times, the fourth root of 81 happens to be 3. Alright, so simplifying. So this is writing the radicals in exponential form and simplifying these radicals. Alright, we might have to I might post a video on simplifying radicals at 5. This is still a little confusing, but let's maybe take a look at a couple examples and see what we know. Alright, so this is part B in this packet. This is fine too. Use what you learned about roots to compute each of the following. So we got 4 to the 3 halves times 4 to the 1 half. Alright, so again, so you're multiplying, you keep your base, and you add your exponents. So this is simply just going to be 3 plus 1, which is 4. Right, keeping my denominator, which is just 4 squared, which is just 16. One way to do it. If you erase this and think about this, right? So you have 4 to the 3 halves power, so you have 4 to the 1 half power cubed, and times 4 to the 1 half power, right? 4 to the 1 half power again is the square root of 4, which is 2, and 2 cubed is 8. And again, 4, and then looking at this one, 4 to the 1 half power is 2 again, and that's 16. So you can do it that way, or you can add them and see which one's easier. I thought adding them in this one was a little easier, but whatever works. All right, 4 to the 1/3 power might be a little challenging, because here's 4 and here's 2. So here's a case that we don't have the same bases, and most of the time I have been giving you the same bases. So 4 and 2 are common to each other because 4 can be rewritten in a form of 2. So I could rewrite, so 4 is also equal to 2 squared. So I can rewrite this as 2 squared to the 1/3 power times 2 to the 1/3 power if you want to. And if you rewrote that, 2 to the 1/3 power, then this is 2 to the 2/3 power times 2 to the 1/3 power. And now, if you notice, you have the same base. So 2, you're multiplying. So you're taking 2/3 and you're adding it to 1/3, right? You're adding the exponents. And this just gives you 2 to the 3/3, or 2 to the first, which is equal to 2. Alright, and then last but not least, or sorry, we got 2 more. We got 2 to the 5/3 to the 3rd power. So this one's cool because you have 5/3 times, and you gotta multiply this product to product over 1. My 3 simplify, and you're just left with 2 to the 5th, 2, 4, 8, 16, 32, and that's done. And then this one, you have division, so you have a base of 25, and you have 3 halves minus 1 half, so 25 to the 2 2s, or 25 to the first, which is equal to 25. Alright, and that's pretty much all of them at this point. And this one for part B. And then we're going to move on to the next one and see what we got here. So we got part C we're going to skip, and we're going to look at part D. Suppose problem 1.4, number of cuts. This is referencing another problem that I'm not sure about, so let's just move on. And I'm going to go to E. Alright, use the rules of exponents to rewrite equivalent expressions. Alright, so this is just multiplying, dividing. Nothing too crazy on this one. I'm going to move on from this one as well. Alright, so let's get to some practice here. So rewrite each in the radical form. Okay, so 7 to the 1/2 power is the square root of 7. So you have a fraction, so you're going to have some kind of root for number 2. Okay. The denominator is the root, and all raised to the 4th power, and then just drop your number in there. Right. So 4 to the 4/3 power is the cube root of 4 to the 4th, and you could write this as the cube root of 4 to the 4th either way, and either answer is fine. Okay. If you want to put parentheses in there, that's fine too. All right. So number 3, 2 to the 5/3 power. So this is my root. So the cube root of, well, there's my base of 2, and all raised to the 5th power. Or again, you could do cube root of 2 to the 5th power, either one. Alright, this one's just asking you to rewrite. It's not asking you to solve anything, just to rewrite them. Alright, so we'll do one more together. 7 to the 4/3 power. So again, that denominator is the root. This is going to be my base, and then raised to the 4th power there. Alright, and then let's do, and it's definitely going to be more practice on these as well. And now let's take a look at the second set here. You can finish 5 and 6 and check out the answer key. Now, going backwards, write the expression in exponential form. So remember, if you have a root and there's no number inside, then it's an imaginary 2. So 10, you're going to have a square root, so there's going to be some kind of fraction here. The root is my denominator, and the power is my numerator. So 10 to the 3/2 power. Alright, so this one as well. So I have 2. I have a square root, or some kind of root, so it's going to have some kind of fraction there, and this is my denominator. And every number is technically to the 1st power, so make sure you put a 1/6 there. So if you just wrote 2 to the 6th power, that's going to be incorrect. It's 2 to the 1/6 power. Alright, so be careful with number 11s like that too. So 2 to the, you have a root, 3 is my denominator, there is no numerator there, it's just to the 1st power. Versus you have number 9, you have 2 to the root is the denominator, and now you have an exponent there, which goes in my numerator there as 2 to the 5/4 power. Alright, let's do one more, and then hopefully this is not too bad. Alright, so 5 to the denominator is the root, exponent is the numerator there. And 5 to the 5/4 power. Alright, and then let's see what else we got here. So we're going to combine a few things. Alright, cool. So we got 5x to the negative 5/4 power. Alright, nice. So remember, this is a negative exponent. Again, a negative exponent does not make this all negative. All this is going to do is, since this entire thing is raised to a negative exponent, well, technically it's over 1. So if I bring the entire thing to the bottom, so this is going to be 5x to the positive 5/4 power, and we have to put a placeholder there. Make sure you put the 1 there. And if you write that in radical form, you get 1 over. So the denominator is the root, so the 4th root of 5x and to the 5th power. In algebra 2, you'll be told that you cannot leave a square root or any radical in the denominator. And then they'll be talking about rationalizing denominators, but we'll take it one step at a time and just write it just like that for now, and that's good for your next assessment. Alright, so 5x to the negative 1/2 power. I'm going to cheat this one and put a big fraction here, make this positive, and make this a 1. So 1 over 5x to the 1/2 power, which is just 1 over the square root of 5x. Nice little cheat there, but and then 10n to the 3/2 power. So again, there's a fraction. You don't have to write the square when it's there, okay? But I'll write it there just for our purposes. And then to the 3rd power. Alright, so we got a couple more examples there. Let's finish this one. So you have fraction is the 5th root of a to the 6th power. Alright, see what else is on here. So now you're rewriting an exponential form. Okay, so I think we just did a bunch of those. And so the rest of this is just really practice. Right, so 19 through looks like 32 can be all practice problems and simplifies. And then you have a section here where it says simplify. Just make sure you simplify all the way to the end and get as far as you can. So let's do one of these. 25 is obviously really easy, so this is just the square root of 9, which is just 3. If you look at like number 28 or something, this is the square root of 36 to the third power. Okay, so you could have chose to put or you could have done the square root of 36 to the third power, and you could cube it first and then square it and then take the square root of it, or take the square root of it first and then cube it. Alright, so again, I could take the square root of it first and get 6 and then cube it, or I can take 36 to its third power first, which I definitely don't know off the top of my head, but 36 to the third is square root of 46656, which I don't know, but I guarantee it's going to be 6 to the third power, or 216. Alright, so obviously this way was a much better choice if I didn't have a calculator. Alright, and then watch your negative signs, but remember your negative exponents do not make your number negative, it just changes the position of it. Okay, and then you have after 32, you're good there. We'll have a little check-in at some point, and then we move on to operations with scientific notation. But in your packet you will have another practice worksheet, rules of exponents. That's definitely a little more complicated than what we've been doing, but definitely good practice for you guys. Okay, so the number is 10 problems. Yep, 10 problems there, and we could definitely use one of our sessions for that. Alright, so this video definitely went a little longer. Take your time, practice, and we'll get some practice of reviews, and we'll review some more with this before we move on to scientific notation. Alright, see you guys soon.